Good morning to one and all present here. Today I am going to share a small article regarding bias and variance. So there is two concepts in data science. One is overfitting and underfitting. So what is overfitting? A statistical model is said to be overfitted when we train it with a lot of data. When a model gets trained with so much of data, it starts learning from the noise and inaccurate data entries in our data set. Overfitting happens when a model learns the detail and noise in the training data to the extent that it negatively impacts the performance of the model on new data. This means that the noise or random fluctuations in the training data is picked up and learned as concepts by the model. The problem is that these concepts do not apply to new data and negatively impact the models generalized. So here then the model does not categorize the data correctly because of too many details and noise. Overfitting should have high variance and low bias. So what is underfitting? A statistical model or machine learning algorithm is said to have underfitting when it cannot capture the underlying trend of the data. Underfitting destroys the accuracy of our machine learning model. Its occurrence simply means that our model or the algorithm does not fit the data well enough. It usually happens when we have fewer data to build an accurate model and also when we try to build a linear model with fewer nonlinear data. Underfitting, high bias and low variance. So, hobby. Chatting, not interested in class, doesn't pay attention to professor. Hobby to be in best in class, mugs up everything, professor says, too much attention to the classroom. Hobby is equal to learning new things, eager to learn concepts, pay attention to class and learns idea behind some. So here we have a guessing of 50%, Mr. No it will know, 98%, problem solving approaches 92%. So this is a professor who is going to deal with this data set. So this situation where any given model is performing too well on the training data but the performance drops significantly over the test set is called an overfitting model. For example, non-parametric models like decision trees, KNN and other tree-based algorithms are very prone to overfitting. On the other hand, if the model is performing poorly over the test and train set, then we call that an underfitting model. An example of this situation would be building a linear regression model over non-linear data. It measures the difference between model's prediction and the target value. If the model is oversimplified, the predicted value would be far from the ground truth, resulting in more bias. Variance measures the inconsistency of different predictions over a varied data set. Suppose the model's performance is tested on different data sets. The closer the prediction, the lesser the variance. Higher variance indicates overfitting, in which the model loses the ability to generalize. Variance is just a measure of how spread out, how scattered your predictions are. So, bias, variance and trade-off. The goal of any supervised machine learning algorithm is to achieve low bias and low variance. In turn, the algorithm should achieve good prediction performance. There is no escaping the relationship between bias and variance in machine learning. Increasing the bias will decrease the variance. Increasing the variance will decrease the bias. At the end, you are not out to just reduce bias or just reduce variance. You want to reduce error. A good practice is to check the training error and test error. That's what really matters, and it turns out you can express error as a function of bias and variance. Next is the k-fold cross validation to avoid overfitting. So we split all of our data that we are building a machine learning model based off into two segments, a training data set and a testing data set. The idea is that we train our model only using the data in our training data set, and then we evaluate its performance using the data that we reserved for our test data set. K-fold cross-validation is one of the most common techniques used to detect overfitting. Here we split the data points into k equally sized subsets in k-fold cross-validation called folds. One split subset acts as a testing set, while the remaining groups are used to train the model. K-fold cross-validation splits the data set into k number of folds, then uses one of the k-folds as a validation set and the other k-1 folds as a training set. This process is repeated k times such that each of the k folds is used once a test test set. The scores obtained from this k times such that each of the k poles is used once as the test set. The scores obtained from the k times training and testing are then averaged to obtain the final score. So the idea, although it sounds complicated, it's very simple. Instead of dividing our data into two buckets, one for training and one for the testing, we divided it into k buckets. So we reserve one of those buckets for testing purposes, for evaluating the test results of our model, and we train our model against the remaining buckets that we have k minus 1, and we take our test data set and that we evaluate how well our model did amongst all those different training data sets. We average those resulting metrics, that is R square values, together to get a final error metric from k-fold cross validation algorithm. Thank you.